Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy, like the Milky Way galaxy, with 100 billion stars, many billions of years old.
Our out of this world lead is way out of this world, 390 light years away. In fact, for context, 1 light year is equivalent to 6 trillion months.
Imagine what you would see if you had a large lens on the Milky Way. Believe it or not, galaxies themselves can also act as lenses. Scientists around the world were left scratching their heads when the James Webb Space Telescope discovered 6 new galaxies that should not exist. Astronomers and scientists can go back in time with telescopes to see how galaxies formed over thousands of years, but no one was prepared for what they saw recently. These previously undiscovered galaxies threatened to destroy established cosmologies and ideas. The researchers said these findings technically should not exist and violate established laws. What are these new galaxies? How did the JWST find them? What are the implications of these findings? Join us in this video as we show how the JWST detects structures that shouldn't be there. The field of cosmology, the study of the universe's largest scale, is exciting and interesting research. As our technology advances, so does our ability to explore the depths of space and uncover beautiful new perspectives. At the forefront of this cosmic exploration is the JWST, named after astronomer James E. Webb. It is the largest and most powerful space telescope ever built, with a main mirror 6.5 meters in diameter, comprising 18 hexagonal sections that open like an origami flower. This large mirror, along with its advanced infrared equipment, allows the JWST to peer into the beginning of the universe. It captured the light of the first galaxies that emerged 250 million years after the Big Bang. The mission of the JWST is to change our understanding of the universe. Its purpose is to reveal the mysteries of the creation of the universe, show the birth of stars and galaxies, the evolution of cosmic structures, and the possible existence of exoplanets. By observing distant objects emitting light in the infrared spectrum, the JWST can reveal the depths of the universe by penetrating dust clouds in visible light. The discovery of new galaxies has huge implications in the field of cosmology. Each newly discovered galaxy represents a piece of the cosmic puzzle and provides clues about its composition and evolution. By studying distant galaxies, astronomers can understand the formation of stars and planets, the distribution of dark matter and dark energy, and the general structure of the universe. The JWST's ability to detect faint, distant galaxies has led to new discoveries. In July 2022, the camera captured images of a galaxy that existed only 620 million years after the Big Bang, the most distant galaxy ever seen. These observations push our understanding of the early universe to new frontiers and reveal the first galaxies to emerge from ancient chaos. What makes this telescope so special and wonderful? The JWST is the largest and most powerful space telescope ever built. It is an infrared telescope, meaning it is designed to detect light in the infrared part of the electromagnetic spectrum. The main mirror of the JWST is 6.5 meters in diameter, 3 times the size of the Hubble Space Telescope, HST. This means JWST collects 4 times more light than Hubble, allowing it to see objects far, far away. The JWST is also colder than the Hubble, operating at -218 degrees Celsius. The lower temperature allows radiation devices to operate more efficiently, making them more sensitive to weak infrared light. The Hubble operates at -123 degrees Celsius, while the JWST operates at -218 degrees Celsius. The JWST also has 4 instruments, each designed to study a different part of the spectrum. A near-infrared camera is the main instrument designed to image in the near-infrared spectrum, the part of the infrared spectrum closest to visible light. The telescope will be used to study many objects, including stars, planets, galaxies, and nebulae. A near-infrared spectrometer will examine the spectrum of objects in the near-infrared spectrum, allowing astronomers to measure the chemical composition of objects and study their motion. The mid-infrared instrument is designed to image in the mid-infrared spectrum, the part of the infrared spectrum furthest from visible light. The device will be used to study special objects, such as dust clouds and stars, in the early stages of their formation. The fine guidance sensor and the near-infrared imager and slitless spectrograph are a combination of 2 devices. The fine guidance sensor will be used to focus the JWST, while the slitless spectrograph will capture images and properties of objects in the near-infrared spectrum. The JWST is a significant advancement over the Hubble, allowing it to examine a different part of the electromagnetic spectrum. Hubble is an optical telescope designed to detect light in the visible part of the spectrum, but the JWST is an infrared detector designed to detect light in the infrared part of the spectrum. The JWST recently discovered 6 new galaxies as part of its mission to look back in time, examining the origin, composition, and formation of galaxies, and searching for exoplanets. These newly discovered galaxies caught the attention of Earthlings and provided unprecedented insight into the early days of our universe. The galaxies described in a new study based on the first data Webb published are so distant that they appear only as tiny red dots in powerful telescopes. By analyzing the light emitted by these galaxies, astronomers determined that they observed them when the universe was still very young, only 500 to 700 million years after the Big Bang. Early galaxies are not surprising in themselves. They are typically dense clouds of hydrogen atoms in space. But the galaxies seen in JWST's images appear very large, and their stars are very old. Experts say the new discovery contradicts existing theories about the early shape and evolution of the universe, and is inconsistent with previous observations from Hubble. Joel Leja, assistant professor of astronomy and astrophysics at Penn State, and one of the authors said, "We have some expectations about the types of galaxies found in the early universe. Studies using Hubble and other instruments often show early, small, blue baby galaxies, objects newly formed from the primordial cosmic fluid, forming stars and patterns themselves. Generally speaking, young stars emit blue light. As they age, they burn fuel and cool, emitting more red light. But in the older galaxies observed by the JWST, astronomers see red stars, which they didn't expect. Nor did they expect to see galaxies larger than 1 million suns. But at JWST's depth of vision, the red dots appear 50 times larger. The largest galaxies in our sample must be 2 to 4 times smaller than the Milky Way," Leja said. Before astronomers start rewriting cosmology to explain how galaxies came together so quickly after the Big Bang, they need to make sure the red dots they see aren't something else. But most other explanations require a completely new concept, Leja added. For example, stars in the early universe may have been unusually bright due to the absence of heavy elements, and we may not have included these in our models. The discovery of stars forming from gas as stellar activity, which was not present in the early universe, would also be exciting and could lead to stars forming in the early universe. The most important thing is that the spectra provide a lot of discrimination to these objects, Leja said. According to research, the distance and identity of these objects are interrelated. If we know the distance, we can identify the object and vice versa. These findings are surprising. Just 6 months after JWST's team reported the first observations from the Great Observatory, scientists have already faced the unexpected challenge of rewriting their assumptions about the early universe. NASA said that when viewed as galaxies, some of the places they discovered resemble supermassive black holes, regions where massive matter accumulates billions of times the sun's mass, and the gravitational field is so strong that nothing, not even light, can escape. However, experts say that although some of the 6 objects they discovered were black, this still indicates a significant shift in understanding. Despite later reports, the magnitude of the discovery suggests that there are 100 times more stars from this period than scientists had previously thought. The idea that the formation of a giant galaxy began early in the universe overturns what many astronomers thought about cosmic creation. According to science, these objects are called cosmic disruptors, and so far, they have lived up to their name. In a later statement from Penn State, Leja said, "We are examining the universe for the first time, but we don't know what we will find. It turns out we found something unexpected that raises scientific questions. It questions the overall picture of early galaxy formation and our understanding of the universe." The first galaxy is very compact and very large and has been named JWST. It is the most distant galaxy discovered so far. Its light travels more than 13 billion years, reaching Earth when it is only 330 million years old. Although JWST was created first, it is quite compact and similar in size to the Milky Way. But incredibly and surprisingly, it is 89 times larger than the Milky Way, allowing us to better understand galaxy formation. The second galaxy, called JWST, is approximately 13.3 billion light years away. The brightness level exceeded astronomers' expectations. It was almost 100 times brighter than expected. This led astronomers to speculate that a population of stars might be forming at a rapid rate, potentially rewriting our understanding of the star formation process in the early universe. The third galaxy, JWST, is approximately 13 billion light-years away from Earth. Similar to previous findings, many heavy elements such as oxygen, carbon, and nitrogen were also found. These elements, essential for life as we know it, are created in the centers of massive stars that explode as supernovae and enrich the interstellar medium. The presence of heavy elements in this galaxy suggests that star formation and supernova explosions occurred in the early universe, an important step in the emergence of life. The fourth galaxy, called JWST, is located in the same region as the previous galaxy and has a very thin structure. This feature disrupts the current model of galaxy formation. Disks are thought to form as a result of gravitational interactions within galaxies, but the early universe was too turbulent to form disks. The existence of this galaxy suggests that disk formation may have occurred earlier than previously thought, which could change our understanding of galaxy evolution. The fifth galaxy, JWST, is rich in dust, an important element in the creation of worlds. Dust provides the building blocks for rocky planets, and its presence in this galaxy suggests that planets may have begun to form in the early universe. The sixth and final galaxy, JWST, differs from the other galaxies in that it exhibits a surprising phenomenon that measures how much light objects are stretched as the universe expands. The galaxy's redshift is slightly lower than expected for distant galaxies. This suggests that it may be in a region of the universe where expansion is slightly slower. This observation may provide insight into the larger structure of the universe. The discovery of these 6 galaxies demonstrates the extraordinary capabilities of the JWST. Its powerful infrared capability allows it to reveal distant galaxies through clouds of dust that block visible light. Scientists believe that near-infrared cameras played an important role in these discoveries. Its sensitivity and wide field of view allow it to capture detailed images of faint, distant galaxies. It also captures light in the near-infrared spectrum, allowing it to penetrate dust clouds and focus on invisible objects. The discovery of these 6 galaxies is a giant leap forward in our understanding of the early universe. While studying distant galaxies, astronomers can understand the formation of stars and galaxies, the evolution of cosmic structure, and the possibility of habitable exoplanets. Additionally, this latest discovery challenges our understanding and theories of how galaxies form. One of the most important implications of these findings is that they show galaxies may form in the universe earlier than previously thought. The JWST detects galaxies that existed only 300 million years after the Big Bang, challenging the consensus that galaxies formed approximately 500 million years after the Big Bang. Second, the discovery of galaxies with massive stars, such as JWST, suggests that star formation in the early universe may have occurred earlier than previously thought. These massive galaxies formed hundreds of millions of years after the Big Bang. This shows that the star formation process in the early universe was very efficient. Third, observations of galaxies with surprising disk-like structures, such as JWST, challenge current models of galaxy formation. Disks are thought to form through gravitational interactions within galaxies, but the early universe was too turbulent to form disks. The existence of JWST suggests that the disk may have formed earlier than previously thought, which could change our understanding of galaxy evolution. Additionally, the presence of heavy elements such as oxygen, carbon, and nitrogen in galaxies suggests that supernova explosions of massive stars producing heavy elements occurred earlier than previously thought. This suggests that Earth's chemical evolution may be faster than previously understood, with implications for the formation of planets and the likelihood of early life. Finally, the discovery of the first galaxies necessitates adjustments to existing cosmological models. These models must account for the early formation of galaxies, the acceleration of the star formation rate, and the presence of heavy elements in the early universe. These observations lead us to rethink existing theories and models to gain a deeper and better understanding of the universe. As new, more powerful telescopes join the journey of space exploration, we can expect more discoveries that will continue to inform our cosmological system. However, recent galaxy discoveries have important implications for future space missions and cosmological research. These discoveries opened new avenues of research and demonstrated the need for more powerful and advanced telescopes to probe the depths of the universe. The discovery of galaxies in the early universe provides a unique opportunity to study the formation and evolution of galaxies in their earliest stages. By observing distant galaxies, astronomers can understand the origin of the universe, the processes that led to the formation of the first galaxies, and how galaxies evolved over thousands of years. The JWST played an important role in these discoveries, and future studies in space are expected to build on this success. Scheduled to become operational in 2024, the Vera C. Rubin Observatory will provide celestial observations that will allow scientists to explore and study many galaxies, including the newest distant galaxies. Space missions such as the Euclid Space Telescope and the Large Synoptic Survey Telescope will allow astronomers to study dark matter and dark energy in detail. This work will provide accurate measurements of the distribution of galaxies and the expansion of the universe, helping to deepen our understanding of the mysteries of the universe. Additionally, the presence of dust in galaxies such as GN7 suggests that planets may have begun to form in the early universe. This increases the likelihood of exoplanets being found in distant galaxies. Finally, the discovery of the first galaxy shows the interaction between different parts of cosmology. By studying the formation and evolution of galaxies, we gain insight into the behavior of dark matter and dark energy, the chemical evolution of the universe, and the potential for life beyond Earth. Future cosmological studies will need to integrate these insights to help better understand the universe from its earliest times to its current state. With these discoveries and more to come in the future, scientists and astronomers will find themselves rethinking our ideas and receive views about the universe and how it works. This definitely wouldn't be a bad thing. Thanks for watching another episode. While you're here, you can watch more space-related video.